Hello everyone, myself Vinay Kumaram. I'm actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I was actually discussing the second chapter of 9th standard science subject, that was, is matter around us pure? So in this particular video, I'll be discussing the exercise. So coming to the first question, here there are set of questions in this particular first question. So in this particular question, you should actually name different techniques to separate mixtures. So coming to the first question in this particular first question, that is A question. In water, there is NaCl. So water plus NaCl is there. You have to remove this particular NaCl from water. So how to remove NaCl from water? Evaporation is the method. So you can actually evaporate because NaCl has different boiling point. Hence at 100 degrees Celsius it won't get evaporated. So water will get evaporated and NaCl will be left behind. And this water can be heated to 100 degrees Celsius and this water can be evaporated. And evaporated water vapors can be condensed back to get water as well. So here through evaporation method you can actually separate NaCl from water. So coming to the B question, here they have asked NH4Cl, NaCl. If there is a mixture between sodium chloride and ammonium chloride, how will you separate ammonium chloride from this? So the process which is used here is sublimation. So you can refer my previous videos where I have actually explained what is sublimation. Sublimation is that process when you actually heat a particular solid. So when you supply necessary amount of heat energy for this particular solid, so this solid will not get converted into liquid. It will be directly converted into gaseous phase. So this particular process is actually known as sublimation. So when you actually heat this particular NH4Cl plus NaCl mixture, so at that particular time this ammonium chloride, that is NH4Cl, will get evaporated directly into gaseous phase, hence leaving behind sodium chloride. So this is how you can actually separate ammonium chloride from sodium chloride. So coming to the third mixture, that is in the C question, they have asked small pieces of metal. So small pieces of metal is actually mixed in oil. So especially they have given engine oil. So how you will separate these kind of small metal pieces which has got mixed in oil? So the method which you can use here is magnetic separation method. So by using a particular magnetic separation method where you will be using a strong magnetic field to attract this small metal from that particular engine oil. So coming to the D question, here they have asked how will you actually separate different pigments from a flower petal? So here the method which is used is chromatography. So there are different kinds of chromatographic techniques which they actually use to extract and separate pigments which are present in the flower petal. So the answer is chromatography method. So coming to the E question, how will you separate butter from curd? So butter is actually a heavy fat which is actually there inside that particular curd. So how will you separate this? When you actually churn the curd or when you actually use some kind of centrifugation or some centrifugal force, because of that centrifugation method, you will actually separate butter. That is the heavy fat which is present in that particular curd. So the answer here is centrifugation of curd. So by using centrifugation, you can actually separate butter from curd. Coming to the F question, there they have asked how will you separate oil and water mixture? One thing which you should remember here is that oil has less density compared to water. So because oil has less density compared to water, oil will float on water. So let's say you have water in a particular container and you have oil in that particular container as well. Oil and water never mix with each other properly. They are heterogeneous mixtures. So there is no homogeneous mixture of oil and water. So oil just floats and creates one kind of layer on top of water like this. So here oil is not homogeneously mixed with water. It is just floating on water. So you can put this into a separating funnel. So separating funnel looks like this. So there will be a valve here to close and open the funnel. So here if you put this particular solution, so water will occupy the bottom part of this particular funnel and oil will float on this particular water like this. So slowly you can open this particular tap and you can collect water in another container here. And whenever this oil level reaches this particular point, you can close this valve and remove this oil from this particular separating funnel. So separating funnel can be used. So separating funnel can be used to separate oil and water. So coming to the G question, here they have given tea leaves and tea. So tea leaves plus tea is the mixture which they have given here. So to separate tea leaves from this particular tea, you can actually use normal filtration method. So filtration method can be used to separate tea leaves from tea. Coming to the H question in this particular first question, there they have given iron pins from sand. So iron is actually a metal, and if this particular iron pins are mixed in sand, you can actually use magnetic separation method. Use a magnet to attract this particular iron pins, and easily this particular iron pins can be separated from the sand. Coming to the I question in this particular first question, there they have given wheat grains plus husk of this particular wheat. So how to separate this wheat grains from husk? Here winnowing is the method which you will actually use. So what do you mean by winnowing? So a particular method where you will actually drop this particular wheat grains which are mixed with husk from a very high level, and you should make sure that wind is sufficiently blowing. So the husk which has very less weight will be blown away in this particular wind, and the wheat grains which are heavy will not get blown away with wind, they will just fall onto the ground. So here you can actually collect the wheat grains. So this process is known as winnowing process. So this is the method which is used to separate wheat grains from husk. Coming to the J question, mud particles, mud actually mixed in water. So how to remove this particular mud particles from water? So normal filtration process you can actually use. So you can use a filter paper. So using this particular filter paper, you can purify this particular water where water is mixed with this mud particles. This particular filter paper have very small pores where only water can be flown through, and this particular mud particles cannot flow through that particular pore. So hence mud particles can be easily separated from this particular water. So this process is known as filtration process. So normal filtration process can be done to separate this particular mud from water, where you are using a filter paper to separate this particular mud particles. So second question in this particular exercise. So here you should actually describe the procedure to make tea. So here you should use the words solution, solvent, solute, dissolve, soluble, insoluble, filtrate, residue. So using these particular words, you should actually describe the steps involved in making tea. So how will you actually explain this? What do you mean by solution? Solution is a homogeneous mixture of solute in solvent. Here you are actually creating solution of sugar and water. So you take water in a particular container. So water will be taken in a container and sugar will be added to this particular water. So here sugar acts as solute and water acts as solvent. So when you actually mix this particular sugar, that is solute in solvent, then you will get a solution. So you can explain this in your own words. So here there is one more word, that is dissolve. So when you put sugar into water, sugar gets dissolved. That means sugar acts as solute and that particular sugar gets dissolved in the solvent and you will get a sugar solution. So now you have used the words dissolve, solute, solvent and solution, where sugar is actually soluble in this particular solution and tea particles are insoluble in this particular solution. So for this particular sugar solution, you are adding tea. So this particular tea is actually insoluble and this particular sugar is actually soluble. So you can use these words and you can explain in your own words. So sugar is soluble in water. Sugar can be dissolved in this particular water. Sugar acts as solute. Water acts as solvent and there is a sugar solution formation. And tea particles will be put into this particular sugar solution where tea particles are actually insoluble in this particular water and this particular solution will be heated. So after heating this particular sugar solution which is mixed with tea particles, after boiling this particular mixture, you will actually filter out the tea particles which are there, which are actually mixed in this particular solution. So in between you can also put one more step where you are actually adding milk to this particular solution. So milk will actually form a homogeneous mixture with this particular water, and also sugar will form a homogeneous mixture with this particular water. So milk and water are soluble in this water, so they form a solution, and to this particular solution you are actually putting insoluble tea particles and you are actually boiling that particular solution. So after boiling, next step you will actually filter out the tea from that particular solution and the tea is ready. So after filtering out this particular tea, whatever remaining tea particles you will get, that is actually known as residue. So you have used all the words which they have given, that is solution, solvent, solute, dissolve, soluble, insoluble, filtrate and residue. So here water and sugar and milk will form a homogeneous solution. So here water acts as solvent, milk and sugar acts as solute, they get dissolved in water, they are actually soluble in this particular water, but tea particles are insoluble in this particular water. So this particular insoluble tea particles are put into this particular solution and they are actually boiled. After boiling this particular solution, they are filtered out. So the remaining tea particles which has got filtered out is actually known as residue. Coming to the third question, there was a student who actually tested the solubility of different materials in 100 gram of water. So how much gram of KNO3, NaCl, KCl and NH4Cl can be dissolved to form a saturated solution in 100 gram of water at 283 Kelvin, 293 Kelvin, 313, 333, 353. So what do you mean by solubility? This I have actually explained in my previous video. So solubility is the ability of a solvent and a solute where the maximum amount of solute is mixed in a solvent at a given temperature. So at different temperature solubility will be different. So at a given temperature, how much amount of solute a particular solvent can dissolve in it. So the maximum amount of solute that particular solvent can dissolve in a particular given temperature. So that particular value will be the solubility of that particular solution. That means after the solubility point is reached, if you add more solute to that particular solvent will not dissolve that particular solute. That solute will just form a precipitate in that particular solution. So the maximum ability of a solvent to dissolve a particular solute at a given temperature will be the solubility of that particular solution, which includes both solute and solvent. So this is actually solubility. So coming back to this particular question, here at 283 Kelvin, KNO3 in 100 gram of water at 283 Kelvin, 21 gram can be put in this particular 100 gram. So 21 grams is the maximum extent where this 100 gram of water can dissolve in it at 283 Kelvin. Similarly, if temperature is increased to 293, then 32 gram of KNO3 can be dissolved in this particular 100 gram of water. But if this particular temperature is further increased to 313, then also solubility will increase. That is 62 gram of KNO3 can be dissolved in 100 gram of water. 333 Kelvin, at that particular time, 106 gram of KNO3 can be dissolved in 100 gram of water. So all these values are in grams. So at 353 Kelvin temperature, 167 gram of KNO3 can be dissolved in 100 gram of water. Similarly, for NaCl also they have given different values. KCl also they have given different values. And for ammonium chloride, that is NH4Cl also they have given different values. Based on this particular question, so now I have explained what is the background of this particular question. So based on this particular background, based on this particular data, there are few other set of questions in this particular third question. So you should go on answering those questions. So coming to the A question in this particular third question. So in that particular A question, they are actually asking mass of potassium nitrate, that is KNO3. So mass of KNO3 at 313 degree Kelvin in 50 gram of water. So what is the maximum mass of KNO3? 50 gram of water can dissolve at 313 Kelvin. So here when you look at this particular data, so when you have 100 gram of water, so at 313 Kelvin temperature, this particular 100 gram of water can dissolve 62 gram of KNO3, this particular 62 gram can be dissolved in 100 gram of water at 313 Kelvin. So at this particular temperature, mass of KNO3 will be 62 grams in 100 gram of water. So what will be the weight of KNO3 if you are using 50 gram of water and the temperature is also same, that is 313 Kelvin. So since temperature is same, because these two are linear variables, that is mass of KNO3 and mass of water, you can cross multiply this particular thing. So when you cross multiply, it will be x into 100 gram is equal to 62 gram into 50 gram. So if you bring this 100 gram to RHS, it will go to the denominator. So that is 62 gram into 50 gram divided by 100 gram. So here 1 gram gets cancelled, 0 gets cancelled, 5 ones are 5 2s are 10, so 2 ones are 2, 3s are 6, 2 ones are 2, 31 grams. So the value of X will be 31 grams. So answer for this particular A question will be 31 grams. So 31 grams is the maximum amount of KNO3 which can be dissolved in 50 gram of water at 313 Kelvin temperature. So coming to the B question in this particular third question, this particular water is maintained at 353 Kelvin temperature and KCl will be mixed in this particular water. So there will be a saturation. So at 353 Kelvin temperature, there will be a saturated solution preparation using KCl. That means there is maximum amount of KCl dissolved in this particular water at 353 Kelvin. So what is the maximum amount of solute which can be dissolved at 353 Kelvin for KCl? So if KCl is a solute at 353 Kelvin, 46 gram of KCl can be dissolved in 100 gram. So at 353 Kelvin, 46 gram of KCl can be dissolved at 353 Kelvin temperature in this particular 100 gram of water. Now this particular student will allow this particular water to cool down. That means this particular water will be cooled down to room temperature. So room temperature means that will be somewhere around 298 Kelvin. So when this particular water is actually cooled down to room temperature, when it is just left like that, it will be reduced to room temperature. So now temperature is not 353. At this particular point, 298 Kelvin will be there. So what will be absorbed in this? This is actually the question. So at 298 Kelvin, that is somewhere around 293 Kelvin to 313 Kelvin, the maximum amount of KCl which can be dissolved in 100 gram of water will be 35 gram and 40 gram. But now we have created saturation solution of KCl at 353 Kelvin. So to make saturated solution, 46 gram of KCl will be used at 353 Kelvin. But now temperature has reduced. So at that particular temperature, the maximum KCl which can be dissolved in water will be somewhere around 35 gram. Because there is reduction in the solubility of KCl in water, when the temperature is actually reduced, there will be extra 11 gram or extra amount of KCl will be forming precipitate in that particular water. Because at room temperature, somewhere around 35 gram of KCl can only be dissolved completely in this particular 100 gram of water. But when temperature was increased, it could dissolve more amount of KCl. That is up to 46 gram of KCl could have been dissolved in that particular water. But now again water is cooled back. So only 35 gram will be dissolved or somewhere around 35 gram will be dissolved and remaining amount of KCl will be not dissolved in that particular solution. It will come back as a precipitate in that particular solution. This is what observation that particular student will do in this particular question. So there will be precipitate of KCl. So precipitate of KCl will be formed when this particular temperature is reduced. So coming to the C question in this particular third question, there they have actually asked to find out the solubility of each salt at 293 Kelvin. So if you just refer this particular table, you will get the answer for this. So for KNO3, it is 32 gram in 100 gram of water. For NaCl, it is 36 gram in 100 gram of water for 293 Kelvin temperature. For KCl at 293 Kelvin, it will be 35 gram in 100 gram and 37 gram of ammonium chloride will be dissolved in 100 gram of water at 293 Kelvin temperature. So this particular second column will be your answer for this particular C question. So here they have asked which particular salt or the solute has highest solubility. You can clearly see here 37 is the highest among these four values. That shows ammonium chloride has highest solubility among all these four salts at 293 Kelvin temperature. So NH4Cl, that is ammonium chloride, has highest solubility at 293 Kelvin temperature. So this particular NH4Cl has high solubility compared to other particular salts which they have given at 293 Kelvin temperature. So coming to the D question, here they have given what is the effect of temperature. So if you observe that particular table which they have given, whenever there is increase in temperature, there is also increase in solubility. So increase in temperature is actually increasing the solubility of that particular solution. So if you watch that particular table in a reverse manner, at that time you can notice that decrease in temperature is actually decreasing the solubility as well. That means solubility is directly dependent on temperature. So if you increase temperature, solubility will be increased. If you decrease temperature of the solution, then solubility will be decreased for that particular salt. So this is all there in this particular video. So like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then please do subscribe to my channel and stay tuned with my channel. Thank you.